Welcome back to Code Snippets. Today we're talking about performing Boolean operations, so working with Boolean. So first, let's declare a Boolean type variable. We're going to follow the same format that we follow for every other variable. So we're going to list the data type first, and then we're going to give it the name, and then we're going to initialize it with something we'll just say true for the sake of example. So before we start getting into any fancy operations, what do we use Boolean values for? Well, anytime you have a Boolean variable or a Boolean value, you're always going to have some sort of if statement. So in this case, the way we write an if statement is if, and then open parentheses, and then inside here, right, this is where your Boolean expression would go. Just like that. And I'm actually going to put this in we're going to comment this out because this is our format for writing an if statement. And I think actually you can write if and then hit control space, and now it'll automatically set up your if statement for you if you hit enter. So Eclipse recognized, hey, you have a Boolean variable called foo, so it automatically put foo in for me, so I don't have to worry about that. So this is just demonstrating how to write an if statement. And of course it automatically encloses the whole thing in the square brackets. And what's very nice about Eclipse is if you click one, or not the square brackets, the opening curly brackets, my apologies. If you click on one of the curly brackets, it highlights the other one for you. So it shows you exactly what's being enclosed. So it's very easy to see. And if we go over here and click this, you can see these ones correspond to each other and these correspond to each other. So again, very, very helpful. So now inside of this if statement, we can run some code. So I'm going to do sysout foo is true. Just like that. Okay, so if we run this, we get the phrase foo is true. So it did run this because we have the true value stored in foo, and then we have if foo, so that's based on this code, foo will always be true, so this code will always run. Now we can change this to false and then run it again, and we see that nothing happened because since foo is false, this line in here, everything in here will not get run because foo is false. So what if we had some code that we did want to run if foo is false? Well, then we can throw in an else statement here. So the else always comes after the if. If you have an else without an if, Java will throw a fit. So if I said else like that, it doesn't like it because it says syntax error on token else, delete this token. It doesn't like it because there's no if statement. So we're going to delete that. All right. So if foo is not true, then we're going to print out foo is false. So now whatever we initialize foo as, it will print out the corresponding values. In this case, foo is false. And again, we can change that back to true. And that's what happens here. Foo is true. Now, what if we wanted to check for multiple conditions? So what if we have two different variables, Boolean foo and Boolean bar? We'll call this true as well. So we'll say if foo, then we'll say else if bar, and then we'll say else. So this is an if else statement, and you can actually have as many else ifs as you want. So in this case, we're going to say foo is false and bar is true. And in this case, we're going to sys out that both are false. Okay. So if we run this, again, we just get foo is true because it checks this condition. And if this is true, it runs this and then skips down to the end of here, right? Past this point right here. Now if we change foo to false, this is where things get interesting. We hit run, and it prints out the foo is false and bar is true. And if we look, that's exactly what's happening. Foo is false and bar is true. And that's because it ran this. And since this evaluated to true, i.e. bar is storing the value true, then it prints out this message right here. It runs this line, and then it exits out of the if statement. So we never hit this line right here because bar was true. If we change bar to false, and then we run it one more time, we get both are false, and that is a true statement, ironically. All right, so this is all fine and dandy, but this can be a little bit tedious and not exactly helpful for most programs. Because if we just assign a static value, either true or false, it's not the most interesting thing in the world, and again, we can't do much with it. So this is where Boolean operations come into play. So I'm going to leave some space in between here, and this is what we're going to talk about. So just like how we had in our numeric operations, just like we have this plus, minus, times, divided by, mod, and all this fun stuff, we also have some operators that belong to Booleans. So, for example, we could sys out, and actually, there are operators that apply to numbers that create or return a Boolean expression. So these are still kind of numeric operators. So let's talk about those first. As in, they operate on numbers, but again, they return a Boolean result. So for example, let's create a few numbers. Let's say int a equals 1, int b equals 2, and int c equals 3. So let's print out let's check if a is equal to 1. So we're going to completely comment all this out like that. And for any of you wondering, whenever I do that instantaneous commenting, that's another shortcut in Eclipse. So any lines that you're highlighting over, if you hit Control and then /, which is where the question mark is, it'll automatically create line comments on every single line, and it'll take them away respectively. So we're going to leave that commented out. All right, so we're going to print out a is equal to 1. So if we run that, we get true. So we turned a number, in fact, we turned two numbers into a Boolean expression. And that's because we used here, this is a numeric operator that returns a Boolean expression. So this is the double equal sign. It is not the same operator as the single equal sign. In fact, if we do that and we rerun it, this gives us 1, right? 1 is not the same as true, obviously. And if we change this to 2, it prints out 2. So clearly, a equals 2 is not the same as a is equal to 2. So having the double equals is how we check for equality. I like to say that whenever you're dealing with these Boolean operators, or the operators that return a Boolean type, you're always going to have two of them, or two symbols in general. Now, of course, there are exceptions. This doesn't always happen, but it's a nice rule to keep in mind to sort of help you remember what operators are Boolean and what operators are just for numbers. So in this case, if we want to check for equality, we always need two equal signs. Now, we can check for equality, or we can check that numbers, how numbers compare to each other, because it's one thing for two numbers to be equal, but if they're not equal, well, that doesn't really tell us much, right? So we can print out whether or not b is less than c. And now, like I said, immediately we have an exception where we're dealing with a Boolean operator, we only have one of them. But I think for the less than and greater than, it's a little obvious that that's going to give you a Boolean return type, because you can answer this question, is b less than c? You can answer that with a Boolean type, either true or false, right? B is less than c. In that case, is 2 less than 3? Yes, so we should get a true for that, and we do. And of course, if we have a less than, we must also have a greater than. So print out a is greater than b, we should get false, and we do. But what if we want to check if two numbers are greater than or equal to, or less than or equal to? Now, if you're dealing with these, the best way to remember them, specifically the order that you type them, is important. The easiest way to remember it is how do you say it. So if you want to check that C is greater than or equal to B, that's exactly the order you use. You always just say, you have the greater than or less than sign first, followed by the equal sign. And again, this goes back to, we have two symbols. So this is very clear that it's a Boolean type operator. So, is C greater than or equal to B? Well, that should be true, and it is. And we can also do print out A is less than or equal to C. And again, that should also be true. Great. Okay, so these are the basics. Now we have one more that sort of fits into this category. This one's a little bit of the black sheep. It's slightly an outlier. This is called the not operator. So the not operator is this exclamation point here, and whatever it follows, it does the opposite of. So if we print out foo, right? Normally, this would print out false, right? But once we put the not operator in front of it, it takes whatever Boolean value it originally had, and it switches to its opposite. So not false is actually true. And if we change bar to true for the sake of example, we can print out not bar, right? So this is not true, which would give us false, just like that. All right. So the not operator can be combined with other Boolean expressions. For example, we could put a not in front of this whole thing and put this in parentheses. So not A is less than or equal to C. So this originally gave us false, or I'm sorry, this gave us true. But since we put the not in front of it, now it will give us false. So that's this one right here. So this one will turn to false when we run it, which it did. That was this one right here. This is now false. And then if you notice, foo is false, but when we say not foo, it switches that false to a true. And bar is true, but when we say not bar, it switches that true to a false, and that's what we have here. So that's all the not operator is doing. It changes your true to a false, and it changes your false to a true. Now, it can be a little bit cumbersome to put the exclamation point and then use the parentheses. So thankfully, for the equals, when we have something like A is equal to 2, if we want to check A is not equal to 2, instead of having to put the not operator, the exclamation point, in front, we can actually just replace the first equal sign with a not. So this would be read as A is not equal to 2, and that should change our false to a true, which it does. That's the very first value that changed there. Now, that's the essence of the not operator. So if we were to apply all of these to our if statements, right, instead of just saying if foo or else if bar, now we can actually use some interesting stuff, such as if B is less than C, else if A is not equal to, we'll say 4. And again, we can string together as many else ifs as we want. Else if not B is greater than A, so on and so forth. And now you don't need to put an else at the end, but if you depending on what code is going on, you may want to. So if we run this, let's see what we get. So we got foo is true, which means B is in fact less than C. And if we put that not in front of it, let's see what happens. So let's run it again, and then we get foo is false and bar is true, which means this is true. So A is not equal to 4, that is true. So as you can see, the not operator kind of affects some stuff, and having some interesting values with A, B, and C also shakes some stuff up too, as well. Instead of just having this boring old Boolean foo equals false and bar equals true. But what if we wanted to check multiple Boolean expressions in the same line? So, for example, in this line, we want foo to be true, but we also want bar to be true. So the only way for this to run, foo, we'll just say both are true. Well, then we use something called the AND operator. So if foo and bar, and again, when we're dealing with Boolean operators, they come in pairs. So there's 2 ampersands, which is the shift 7, how you get that. So if we put both the ampersands, if we make both of these true, right, then we get both are true at the end. I'm actually going to comment all these out so we don't keep getting bombarded with trues and falses. So we get both are true because foo is true and bar is true. So in order for this whole thing to be true, both foo and bar need to be true. If one of them is false, then we get something different. Foo is false and bar is true. Well, that's not the case, but that was just the else if. So here, let's change this. Let's change it to foo is true or bar is true. So as long as one of them is true, we'll hit this else if. So to do the or, we need the pipe operator, which is, it should be right above your enter key if you're on Windows. It's the same key as the backslash. It's in the QWERTY row, all the way at the end. So foo or bar. So as long as one of those is true, then this message is 1 is true, just like that. And then for the else, if we reach the else, that means both are false. So if we run this, we've got 1 is true. And if we look, that is the case. Foo is true, but bar is false. So if we change foo to false as well, we get both are false. So this is how we combine Boolean expressions. We either use the double AND or the double OR. Now, with the double AND and the double OR, you can actually use a single one, just like that, just a single ampersand and a single pipe operator. But using 2 of them is actually more efficient because of something called short circuiting. So for example, let's say foo is false, right? So if we check foo and bar, well, if foo is false, that means the whole thing must be false because, if one of them is false, there's no way that this whole operation could possibly be true. When we have the 2 ampersands, as soon as it finds that false, it stops running the code. If we just have the single ampersand, it'll still check the value of bar, even though it knows that there's no way the whole thing could possibly be true. This is getting into the nitty-gritty of programming and sort of the nature of code, but there are some practical uses or applications to having just the single ampersand or the single pipe operator, especially when you're dealing with something like recursion or when you have methods as your Boolean expression operations. And I have not gone over methods, and I won't for at least a couple more videos. So if you don't know what a method is, that's completely fine. Don't worry about it. I will talk about that later. And of course, going back to this, we can have multiple of these expressions all linked together with as many ands and ors as we want. So if foo and bar and a equals 1, right? We can just keep going. But as soon as you start mixing and matching, then you have to make sure that you're being very clear, because Java will let you do this, but it's not clear what we're separating, like as long as what and what or what. So that's when you got to use parentheses, because I can have parentheses here, right? So as long as all 3 of these are true, or the b is greater than c, or I can move my parentheses to here, and this means something completely different, right? If I had parentheses here. So either one of these has to be true, and both of these have to be true. So it's a very, very different meaning. So as soon as you introduce that second pair, or that if you have ampersands, as soon as you introduce the pipe operators, you need parentheses, and vice versa. If you're working with pipe operators, as soon as you introduce those ampersands, you gotta put those parentheses so that it's clear to not only you, but to your program as well, and anyone who might be reading the code that you wrote, if you're working on a team, just so it's exactly clear what your program should be doing, and it makes it much easier to debug if you have a logic error. So that'll do it for Boolean operators. In the next video, I'll be talking about getting user input using the scanner. So that's a huge part of building programs and why we program. It's so that programs are dynamic. It's not just running the same exact code over and over. It's different every time you run it because the user inputs different numbers and different values every single time it's run. And it's like a calculator. If you opened up your calculator and it always just said the number 14, that's not a good calculator. A good calculator needs to account for user input and display dynamic results every time it runs its programming. So that's what makes a program useful. So that's what we'll be covering next time. So I will see you then.